Hello and welcome to azuremonk.com. This is the less than 5-minute explanation of Azure Front Door. Before we begin, let's start off with what an Azure Front Door is. Azure Front Door is a service designed to implement scalable and secure entry point for fast delivery of your global applications. Okay, let's break that down into plain English. Let's take an example where your apps are hosted in New York City and your users are in Miami. Now, without an Azure Front Door or an application delivery network, if the content needs to reach the user, well, it would be akin to taking a cab from New York City to Miami. That's no fun, is it? Now, let's replace this, but this time with a typical application delivery network. As a result, what would now happen is it would be like your content took a flight from your backend location to the point of presence, also known as POP. One of the advantages of using a regular application delivery network is that, let's say there are 1000 connections made to a single point of presence site, the number of backend connections that need to be made to your web server drastically reduces since these connections can be reused. Well, that's not too bad, is it? But wait, there's a catch. This traffic from the backend server to the point of presence still goes out through the open internet. Now, let's look at what would happen if we replace this with the third scenario using an Azure Front Door. With an Azure Front Door, we ensure that the traffic always remains inside the Microsoft Global Network. To understand why this is important, let's take a step back. Microsoft has the second largest network out there in the world. It has 54 regions worldwide, more than 100,000 miles of fiber and subsea cable, more than 130 edge sites, and more than 200 plus express route partners. Now, let's go back to our analogy. This connectivity from the backend server to the point of presence happens over a premium global Microsoft network. Even if your backend environment is not hosted on Azure, you can still leverage Azure Front Door to offload the traffic to the nearest exit. Now let's look at some of the key characteristics of an Azure Front Door. Let's start with active probing. Let's take an example of the following point of presence servers and the following backend resources. As soon as one of the backend servers goes unhealthy, the failover happens automatically to another available backend. And because this is in the data path, the failover is instantaneous. Let's now talk about any cast failover. We talked about unhealthy backends. Let's now talk about an unlikely event where a point of presence server itself goes down. Because the point of presence servers are anycast based, the DNS points to one or two IP addresses globally. And if one of the point of presence servers goes down, BGP auto-magically does the failover to the closest POP. The next characteristics is the DDoS and the web application firewall functionality Azure Front Door provides. Because Azure Front Door works at layer 7 and only handles HTTP and HTTPS traffic, it provides you protection against the layer 4 DDoS attacks by dropping all non-layer 7 traffic at the edge. The other key things you can do with Azure Front Door are IP-based restriction and geography-based filtering. Azure Front Door also provides you with global domain and certificate management with a massive SSL offloading capability. You can manage hundreds of custom domains, and you can also request certificates managed by Azure Front Door, and there are no charges for the certificates. Now that we understand the key characteristics, let's see how Azure Front Door picks the right backend using routing. Unlike Traffic Manager, which provides custom or nested profiles, Azure Front Door provides a fixed routing methodology. Let's say we have 6 backend servers A, B, C, D, E, and F. The first level of filtering happens based on the availability of the backend servers. In this example, since server D is not responding or down, it's removed from the pool of available servers. The next level of filtering happens based on the priority that was set when Azure Front Door was configured. The servers with the highest priority are now considered. Therefore, E and F are dropped since they have a priority of 2. That leaves us with A, B, and C. Next, we consider the latency signal based on the health probe. This is configurable too. If we set the latency sensitivity value to 0, it by default takes the lowest latency. However, in this case, let's say we had the latency sensitivity set to 30 milliseconds. So C gets dropped because it is beyond 30 milliseconds from the closest backend, that is A. Lastly, we use weights to distribute the traffic between these two backends. The traffic is distributed based on the weights assigned. In this case, between A and B, traffic will be distributed in the ratio 5:8. Let's now look at some of the frequently asked questions around when to use which load balancing service in Azure. Let's broadly classify using the following quadrants. When you need a global and a layer 7 load balancer, the service you're looking for is Azure Front Door. Similarly, when you need a regional and a layer 7 load balancing capability, you want to stick with Application Gateway. When you need a global and a non-layer 7 load balancer, you would not go wrong with the Traffic Manager. And lastly, for a regional and a non-layer 7 load balancing option, you always have your good old friend Azure Load Balancer. Thank you for watching. I really hope you found this useful. For more videos, please check out azuremonk.com.